In this tutorial, what we're going to look at is how to do numerical root finding. Numerical root finding is one way of finding solutions to an equation. It's one of many ways that we'll have. The equation that I've selected for this is x squared minus 3x minus 5 equals 0. There would be many ways we could look at solving this or finding the solutions. We're going to look at a numerical root finding method. And so what I've done is I've again put the x values from -10 to 10, and I'm going to put in this equation now for our function, and we get x squared minus 3 times x minus 5, and then we'll fill that down with our little shortcut, and we're going to focus in this particular method on the numbers. That's why they call it numerical root finding. A root is a solution. It is also an x-intercept. Those three names are pretty much interchangeable. And if you are an x-intercept, that means you are on the x-axis. It's where the graph crosses the x-axis. So here are different values of that, the y values of the graph, and you'll notice as you look at them, you can see that between -2 and -1, it changes sign in the y. That indicates that the graph has crossed the x-axis because it's gone from being positive to being negative. So we know that the root, one of the roots of this function is somewhere between -1 and -2. Now if we'd like to find out more precisely what that is, we can do that. We simply come over, we start our new x values. Let's just start at -2. This time we're going to jump by tenths because we want to zero in on this. So -1.9 and -1.8, and then we'll let Excel finish filling that out till we get down to -1. So we know it's somewhere between this -1 and this -2. And now what I do is I'll copy Command C on the Mac. I like to use the keyboard shortcut. Command V paste. We just pasted it. And you'll notice that the y value for -2 is still 5, the same as it was over here. Then what we'll do is we will fill this down, and you'll notice that the -1 is -1. It still matches with what we saw over here, but now we have the values in between, and we can see that the sign change takes place somewhere between a -1.2 and a -1.1. So now we're even more accurate on where that root is located. If we want to get more precise, we'll just pop down here and we'll start with a -1.2, and then, whoops, and then we'll go to -1. Let's see, we want 19, and then we want, we're going down by hundredths, -1.18. Let's see if this can figure out what we have been doing. So this one will go down. We need to go down to -1.1. So as we copy this, we should still have it there. I'm going to just paste and see what happens. Nope. That's not the right one. Let's come up. Let's just try this. Copy and paste. I'm not quite sure why that didn't work. But 1.2, it agrees with right here. So we should be able to fill down. And when it gets clear to negative 1.1, it should agree with our negative 1.1 up here. Now we can see that it's somewhere between a negative 1.2 and a negative 1.19. So if we want even more, so this is, we've got it now to the nearest, we're out to the hundredths place. And if we needed to go to a thousandths, we can say, well, it's between negative 1.19 and negative 1.2. And all we'd have to do is go again to we'll go negative 1.2. I'll put, and then we're going to jump by thousandths this time. So this is going to be negative 1 point, let's see, we want 199 and negative 1.198. And let's see if we can figure this out, if it can figure that one out. That shows that we're actually if I can, let's see, get this to go down to there, and we will copy and paste our, okay, we'll now fill down, and we'll notice that that agrees with our on both ends. And so we can see that somewhere in between now negative 1.192 and negative 1.193 is where the sign change takes place. So we know to the nearest hundredth it's negative 1.19. If we want to know to the nearest thousandth, we need to go out and do this again. And whatever level of accuracy we're looking for, we can determine that to whatever decimal point we need to. Now, you'll notice that that's only one of our roots that we've located, or at least honed in on. You'll notice up here also there is a change of sign between our x being 4 and 5. It goes from negative 1 to 5, so it crosses the x-axis there. So we could again use this to hone in on the other root if we needed to whatever level of accuracy we wanted to on that as well.